In this lecture, I want to explore an extremely rare case where you will need to do your three-way comparison operator and your equals operator in C++20 as non-member functions. But before I do that, let's make something super clear. In more than 90% of the cases, you will need to do your operators as member functions in C++20, and that's going to work. The compiler is going to kick in and flip things around to make things work to your advantage. So develop a good habit to do all these comparison operators, the three-way comparison operator, the equals operator as a member function, because that's going to make your code easier. But I am going to show you a rare case where you might need to do these operators as non-member functions. Okay, so this is going to sound crazy, but bear with me, you're going to see the point of all this. We have a point class, and it has a type conversion operator, which is going to be converting from point to a number type that we haven't seen yet in this lecture. With this point class, we want to do this kind of comparison here. So we want to set up 2 point objects and we want to compare them using the greater than operator. But if you go back to our point class, you're going to see that we don't have any operator. And we want to rely on the operators that are overloaded in the number type that we can implicitly convert to. So what we really want is for the compiler to insert implicit conversions from point to number when we do something like this, even if we don't have any number object in this comparison that we are doing here. And this is going to be really weird. I couldn't really think of a case where I might want to do this in my code because this is just going to be confusing. I wouldn't recommend you to do this, but I had to come up with an example to show you that it is at least technically possible to do your three-way comparison operator as a non-member function. That's the point of this lecture here. So this is what we're going to do. We're going to be trying to compare point objects, but our point class doesn't have any operator. We're going to rely on the operators from the number class that we can implicitly convert to from our point class here. And let's look at a possible implementation for the number class. The number class might do what is recommended and set up its comparison operators as members. And the code we had in the main CPP file that compared points is not going to work in that case because implicit conversions don't really work for the left operand. So the compiler might look at the comparison here and try to convert P1 to a number and P2 to a number, but it is not going to do that because implicit conversion are not supported on the left operand if our operator is done as a member function. So if we set up something like this, this is not going to work and we are going to get a bunch of compiler errors. If we want implicit conversion to kick in, we need to do what we have been doing all along. We need to do our comparison functions as freestanding non-member global functions. And this is a simple example of how you could do that. We could do our three-way comparison operator. It's going to take 2 parameters. One is going to be the left operand. The other is going to be the right operand. We're going to do the same for one that takes an operand that is an integer, to be able to use integer operands or literal operands because this guy is explicit. So it's not going to allow implicit conversions from integer to the number type. We already know that. And we're going to put in our equals operator. One is going to be working on 2 number objects. The other is going to work on an integer on the left and a number object to the right. Once we do this, our implicit conversions are going to kick in. This code here is going to work. The compiler is going to take the first operand and turn that into a number. It's going to take the second one and turn that into a number. And then it is going to compare them as numbers. And we're going to see the result printed out if we print this here. This is one rare case where you might need to set up your three-way comparison operator as a non-member freestanding global function. In all other cases, I would recommend to set up your comparison operators as members because that's going to make the code easier. Now that you know this, we're going to go to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is Spaceship as non-member. We are going to reuse the code from the last lecture because we're going to need the number class. So let's grab everything from there. We're going to copy the code and we're going to put that in our current project. We're going to open this in Visual Studio Code, and this is going to give us our starting point. We're going to open our number class and we're going to take out all the other things we don't need here. We don't need all these crazy operators from the last lecture, so we can take them out and clean up a little bit to make our code look nice. And we're going to go in the CPP file and clean up as well. Let's do that. We're going to remove everything that is commented out here. We can do that. And this is going to clean up our code here. Now, what we want to do in the main function, we're going to take out the code here because we're not going to be reusing this. Instead, we want to set up a point class that is going to just have two member variables of double type. It is a simple class, that's why I did it in the main CPP file here. But the special thing this class has is a type conversion operator, which is going to convert from the point type here to a number type. And if you go back to our number, you're going to see that it has all the operators to compare things logically. So this is something we would want to take advantage of from the point class because we don't have our own operators. And we are going to take advantage of that by setting up 2 point objects, 10 and 20. This is the data in here. And we're going to do our comparison and hope that the compiler is going to use our conversion operator and turn our points into numbers and then compare them and then give us a result. Again, I don't think this is really meaningful in practice. I couldn't think of a way this could be useful, but this is a technical possibility and I needed you to be aware of this. That's why I am showing this here. But as you see here, we have a squiggly line. This is really not going to work. Our comparison operators are done as member functions. And as you already know, if your operator is done as a member function, implicit conversions are not going to work on the left operand. That's the problem we have here. The compiler is going to look at what we are trying to compare here, and it's going to see I can't really convert the left operand because I don't know what I would convert it to. So it is going to give you a compiler error because it can't really implicitly convert to the number type on the left operand because our comparison operators are done as member functions. If we want this kind of implicit conversion to work, we need to do our three-way comparison operator and our equals operator as non-member freestanding global functions. So let's do this and show you that the code is going to work. We're going to comment out what we have here. And I am going to go down and just put in the code. We're going to do this in our header file. And because it is in the header file, we're going to mark this as in line to avoid one definition rule violations. And now, if you go back in the main CPP file, you're going to see that this is going to work now. The compiler is going to convert these guys to numbers using this type conversion operator. And then it is going to compare numbers and give us a result. So point 1 is going to convert to a number of 10 because our conversion is just using the mx member variable. And P2 is going to convert to 20. And P1 greater than P2 is going to evaluate to false. If we build and run this, that's what we're going to see. We can build with really any compiler that supports C++20. But let's use GCC. We have just used clanged by error here, but it is going to work. No big deal here. So the build is good. We can clear. Let's bring up a PowerShell window. And if we run Rooster, we're going to see that the comparison evaluates to false. We can even go in and print something in our type conversion operator. We can do that. We can say converting mx. We can say that. And if we build and run again, we're going to see our output here. Let's build with GCC because that's what we use. In most cases in this course here, we're going to clear and run rooster. And we're going to see that our type conversion operator is going to be called converting 20 and 10. And we are going to be comparing 20 and 10. And P1 is in the first position, which happens to be a 10. So 10 is greater than 20. This is going to evaluate to false. And that's what we see printed out here. This is really all I had to show you in this lecture, showing you that in extremely rare cases, you will need to do your comparison operators in C++20 as non-members, freestanding global functions. But this is not something you're going to do in a common way. So I would still advise to do all your comparison operators in C++20 as members, and let the compiler kick in and do all the rewrites it needs to do to get things right as you want. We are going to stop here in this lecture, and starting in the next one, we are going to do a bunch of examples really playing with different types of ordering that we can have for our three-way comparison operators to really drive this home so that you can use this flawlessly in your C++ code. So go ahead and finish up here and meet me in the next lecture.